Hello, welcome back. So today I'm posting a video for the chi-square test in week 4. So here's your assignment that's up on the screen, chi-square test, and it gives you 4 different tests that I'd like you to do. And so let's get started. So we're going to do chi-square test lots and lots.save. That should be as part of your assignment, the data file. So bring that up through SPSS, and let me bring this over here to the side, and let's open up the SPSS here. All right, so let's go with the first one. Once I show you one, you can go ahead and do the same thing with all 4 of them, with the other 3 on your own, okay? All right, so what we want to do here in the chi-square is we want to see if there's a relationship between two variables, okay? And one of the assumptions here is that the data cannot be continuous. When we did the t-test was specifically for continuous data. And that means not a Likert scale. Remember, continuous data is data that can be subdivided forever, and it's a standardized measure like pounds or years and that sort of thing. So chi-square is when you don't have those kind of data. When you have nominal or you have ordinal data, you need to have some measure that you can use, so you can still see a statistical significance in the relationship. So in the chi-square, we want to see if one factor somehow is related to the other factor. So what we're going to do here is the first assignment is sex and age group 1. So we're going to go up to Analyze, Descriptive Statistics, Crosstabs. Okay, in Crosstabs, you see I already have these set here. So I'll do it again. As a general rule, the row is for your independent variable and the column is for your dependent variable. But you could decide with 2, 3, and 4 if those are going to have dependent and independent variables. But here, 1, it doesn't really matter which one it is. We're doing age and sex. We're not hypothesizing that one influences the other one in one direction. We're just saying that there might be a relationship between the two. So it's not that one might be affected by the other necessarily in one direction. So it doesn't really matter in this case which one we put in row, which one we put in sex. Okay, so in statistics, we want to check off a chi-square, and that'll give us the chi-square test result, and also the phi and Kramer's V. This will give us a test of effect size, how powerful the relationship is. So in the chi-square, it'll tell us if there's a relationship, if it's statistically different or not, significant or not, and the phi in the Kramer will tell us to what degree it's strong, to the effect size. And the best way that I can explain effect size is if you're doing a statistical test where you want to see if a certain cold remedy has the effect of decreasing symptoms. If you run the test, you can see, well, the difference between group A and group B, the guys who took the remedy and ones who didn't, there is a difference, and yes, it's statistically different. So yay, the remedy is successful, but the effect size show that the effect is very weak. So before you run out to buy that medicine, you need to realize that although there was a significant difference, the effect is very, very weak. So you may not want to buy that. Okay, so that effect size is very important and goes hand in hand with the statistical significant test. Okay, so here chi-square, phi, and Kramer, click that. And then in cells, we want to go ahead and click observed and expected. That'll give us a little bit more information. Observed is what is the actual data that you have in there, and expected is if you're looking at the proportions between the two variables, this is what you can calculate as what you would expect. Okay, so let's go ahead and hit click and OK on that. And this is what the tables that you have. Okay, so in the cross tabulation, you have the male and the female, and you have these down here. Okay, how many were between 21 and 30? How many were 40 to 50, etc. And you can see the actual count, and calculating the percentages between the age group and the sex. This is what you would expect the breakdown to be, and there's a difference. Okay, but how significant are those differences? Okay. All right, here's your chi-square test. This is the meat of your test here, okay? So what you want to look here in the chi-square is the value of the Pearson chi-square, okay? 8.7, and to what degree it is significant. And we also have to consider for our assignment the assumptions. So let me read off a few assumptions that I noted down here, okay? Okay, the two variables we are looking at have to be either nominal or ordinal. Remember that they cannot be continuous. Also, number 2, in your data set, no cell should have an expected value of less than 1. Okay, so you look at your raw data for that. And no more than 20% of the cells should have an expected value of less than 5. Okay, so look down here too. It says 0 cells have expected count less than 5. All right, so it tells you here whether or not the assumptions have been violated. Okay, so if the assumptions have not been violated, let's look over here. All right, is it the result for Pearson chi-squared? So we're looking at the significance. Is it less than 0.05? If it's less than 0.05, the relationship is significant. It's worth noting. All right. So indeed, 0.033 is less than 0.05. Therefore, it is significant. Now, the Pearson value, that's the degree to which, or the percentage of which, one variable affects the other. Okay. So that's the meat of it in terms of significance. So once we see that we haven't violated any assumption and the significance is good, then we can look down here, see if I can scroll down there, down here to the phi. Okay. All right. Here, again, we need to see if it's significant or not. If it's not significant, we don't look at any other numbers. Okay, so is it less than 0.05? Yes, it is. So the effect of the phi test is significant. Now we look at the value here. This tells you the effect size. The closer it is to 1, the stronger the effect size it is, to 1.0, all right? So 0.198 isn't really all that strong. So if you look at a scale of 0 to 1 and 0.5 being like halfway between strong and no effect, you can say that 0.5 is like a nominal effect and less than 0.5 is weak, and 0.19 is actually pretty weak. So depending on what publications you look at, you'll see the scale of 0 to 1 change a little bit, from one publisher to another. But 1 is a perfect correlation, perfect effect size, very strong. 0, no effect size, nothing's happening. And 5 is like in the middle. And 0.198, I would say, is very weak. Very weak effect size. So what we're seeing here is that the Pearson, it has one of the variables is related to the other, or they're related to each other to a decent degree. Okay, and this tells you the significance of that relationship. There is a significant relationship, and there's a significant effect size, but even though it's significant, it's actually pretty weak. So you might say, well, there's a contradiction between those two. But again, with my example of the cold remedy, studies will show that taking this pill will decrease the number of sneezes and coughs that you have. And you go, well, yeah, okay, I'll buy it. But and if you count the number of symptoms before and after in the control versus the experimental, yeah, the fact that it's significant tells you that the pill did do something. If it wasn't significant, that would mean that the chances of the number of symptoms going down could have been just by luck, or by taking a good walk, or having a nice sleep. It has very little to do, if anything, to do with the pill you just took. So the fact that it's significant means that, yeah, it wasn't due to the walk. It wasn't due to the fact that you had a nice night's sleep or you drank a lot of water. No, it had everything to do with the pill. The pill did have some effect. Then you look at the effect size to determine how much did the pill, help. And if it's minimal, then you might want to, not buy that pill. If it had a greater effect size where, you had 100 sneezes per minute and you took the pill and boy, it went down to 1, that would have a very strong effect size. So it's not a contradiction. You can have a statistically significant difference effect, but the effect size is very weak. Okay, so hopefully this will help you. Apply these steps to all 4 of these chi-square things, and just remember that the t-test is a test that we use for continuous data. Chi-square is what we use for nominal or ordinal data, because you don't always have just one or the other. And do your best to write this up, play this back. When you read your book, I know that a lot of pages were assigned each week. To help you out, just look at the assignment, listen to the video, look at what I post on the class, and just read what you think you need to read. So don't, I didn't mean to overwhelm you all with as much as I assigned. So if you have any questions, please ask specific questions on email, and I'll either just answer your email, or I'll answer your email, and I might make a video that others can benefit by. Okay. Well, thank you very much for listening again, and good luck figuring this out and posting your interpretation, and I'll look forward to grading them. Okay. Have a good one.